Alright, here we are with the first lecture video for Math 75X. Welcome to Math 75X. So, just a real quick how my notes look. They'll have the lecture number up in the top and then the section that we are covering in this lecture right over here. So we're covering Chapter 1, Cluster 1. And we're looking at the properties of arithmetic. So, properties of arithmetic, it's basically talking about if you have a bunch of operations in a problem, the question is which operation are you going to do first? For example, if we look at this, where do we start? So how we remember the order is by this acronym PEMDAS. Alright, what does it stand for? What does PEMDAS stand for? Okay, well, the P stands for parentheses. So if you see parentheses, or in this case it says a grouping symbol, if you see parentheses in the problem, you're going to start with those first. Once you've done that, then you look to see if there are any exponents. Well, for refresher for what an exponent is, if you have like a number 5 and it's raised to some power, that little 2 there is the exponent, and the base is 5. Alright, and then the next thing is, so this is where sometimes there is some confusion, so please remember this is important. MD. Okay, so M stands for multiplication, and D stands for division. But these two operations have the same priority. So if you're coming across a problem, like for example, let's see B, see here's a division and a multiplication, we would first do the division because he came first. Alright, so let me read this. Even though M for multiplication in PEMDAS comes before the D for division, these two operations have the same priority. So, perform the two operations in the order they come, so from left to right. Just like how we read, in a book or something, you read from left to right. We're going to do the operations from left to right. Alright, so the next part in PEMDAS, we have the A and the S. So, A is for addition in PEMDAS, and S is for subtraction. But, just like the multiplication and division, these two operations have the same priority. So, what we're going to do is, when you see these two operations, you're going to do the same thing, left to right, and complete them in that order. Alright, so this is the idea for PEMDAS. Let's go ahead and work on some examples. If you want to pause the video at any time and try some of these examples by yourself, by all means, go ahead and do that. Alright, so, example 1. Let's see. So the first thing I'm going to check is, do we have any parentheses? No, we don't. Okay, so we're not going to look at that. How about exponents? I don't see any exponents, so next thing, multiplication or division? I do see division, but no multiplication. But that's alright, so what I'm going to do is do that division first, and that is between these two numbers. So 12 divided by 4, what is 12 divided by 4? That's 3. So notice I'm going to go ahead and, as I'm solving, I will be using equal signs. And sorry if my video keeps bumping in and out of focus, I have a wobbly table, which I plan to fix. Alright, so my equal sign here, showing that I'm simplifying this. So I'm just going to drop down the 20, because I haven't done anything with it, and just drop down the minus sign. But I'm doing 12 divided by 4, which is going to be 3? Yeah. And then drop down the plus and the 1. Alright, awesome. We got rid of multiplication, division. Last thing to check for is addition and subtraction. Ooh, and we have both. So my question is, which one do we do first? Well, remember, we're just going to look from left to right, which means the subtraction comes first. So 20 minus 3 is going to be 17. And then plus 1. 17 plus 1 is going to be 18. Alright, one thing to note for Math 75X, for your first exam, you're not supposed to use a calculator. The rest of the exams you are allowed to use a calculator, but for the first exam, all of your work must be shown by hand. Alright? So, sticking to that would be good. Okay, so, next one, B. Oh, before I move on, boxing our answers is always important. So one thing I'm going to be looking for as you turn in your notes is that you show your work correctly, because this is really the only chance in this class that I have to check your work. Alright, and that's one of your student learning outcomes for this course. So I just want to check to make sure you got your equal signs lined up so I can follow your work, and that you've boxed your answer so it's neat and clear, and I can understand what you're trying to communicate to me. All right, so next one, B. Let's see, do we have any parentheses? No. How about exponents? Aha, we do have an exponent. Ooh, right here. 2 squared. So first things first, we're going to do that. The question is, what is 2 squared? Well, that is 2 times itself how many times? 2. So the exponent tells you how many times you're going to take the base and multiply it to itself. So that's going to be 2 times 2, which is 4. So for example, if I'd had 2 to the 3rd power, that's saying take 2 and multiply it to itself 3 times. So that would be 2 times 2 times 2, which would be, well, that's 4. Bring down that 2. That's going to be 8. So 2 cubed would be 8. But that's not in this problem. That was just an example. All right, so let's write this down. We're just going to copy everything else down because we haven't done anything to those. All right, so we've done the exponents. What's next? Multiplication or division? Ooh, I see division and multiplication. So which one do we do first? Well, left to right, division comes first in this case. So let's do this division right here. Dropping down the 8. 8 plus 12 divided by 2 is going to be 6 times 4. All right, we've done the division. Next. Oh, we have that multiplication we're going to do. So we're going to go ahead and do the multiplication. All right, that's going to be 8 plus 6 times 4 is 24. All right, last thing, we have addition. So adding that up, let's see, I don't remember quite what that is, or, well, maybe I do. But how would we add those up? That's going to be 24 plus 8. 8 plus 4 is going to be 8, 9, 10, 11, 12. So we'll carry that 1 for the 12 and drop the 2. Okay, there is nothing here, so that's just going to be 2 plus 1, which is going to be 32. All right, so remember, for the first exam, everything needs to be done by hand, all right? Unless you happen to know it in your head, that's good. But if not, please do not use your calculator. You're showing things by hand. All right, and once again, I boxed my answer and my equal signs are lined up. Last one for this. All right, let's see. Ooh, this one looks weird, huh? Okay. I don't see any parentheses, but I do see this weird square root symbol here. Okay? So the square root is counted as a grouping symbol. So that's the first thing we're going to do. So we're going to take a look inside the square root symbol. Okay, so let me just rewrite this. Let's see what's inside here. So this is the square root of 4 squared plus 3 squared. All right, so we have addition going on inside the square root, and we have exponents. So ask yourself, which one should come first, the addition or the exponents? Well, remember, according to PEMDAS, exponents need to come first. So let me just do this on the side. We have 4 squared and 3 squared we're working with. So 4 squared is going to be 4 times 4, which is 16. 3 squared is going to be, yep, that's right, 3 times 3, which is 9. All right, so writing that down, 4 squared was 16. Copy down the plus sign, and 3 squared is 9. Awesomeness. All right, so we did the exponent. What else is inside the parentheses we need to work with? The plus symbol. So what is 16 plus 9? If we're not certain, we can go ahead and work that out on the side. 16 plus 9. Well, 9 plus 6 is going to be 15. And then adding those two is 25. All right, so this is going to equal 50 all over the square root of 25. Well, now there's nothing left to do inside this radical, so all we have to do is see, can we simplify the radical? Well, so might be a refresher for you, but what is the square root asking us? The square root is asking us what number times itself, so times itself, will give me 25. That's what it's asking me, okay? So it wants to know, Oh, sorry, that radical is not supposed to be there. What number times itself would give me 25? I'll try and think. Let's see. 4 times 4 was 16. 5 times 5 is 25. So, the square root of 25 is going to be 5. Alright, because remember the square root's asking what number times itself gives me 25, and the answer to that is 5. Alrighty. So this is going to be 50, and then the square root of 25 is 5. Let's see, can we simplify this? 50 divided by 5. That's going to be 10. Alright, and there we go, boxing our answer, and we're done. Alright, that was it, page 1. Let's move on to page 2. Remember, if anything is going too fast, feel free to stop the video, rewind it, and listen to it again. Alright, so new topic, scientific notation. Alright, so scientific notation, generally we use it when numbers are really, really large or really, really small. Okay, so when it has tons of zeros in it, we like to try and condense it into numbers we're more used to working with. So normally scientists would end up using it, which is kind of why it's called scientific notation. Alright, so let's read this. Scientific notation is defined as a standardized way to represent any number as the product. Okay, what does product mean? Product is multiplication. So the product of a real number and a power of 10. Basically, some real number like 1.2, 1.5, something like that, times 10 to some power exponent. Okay, so that's what scientific notation looks like. But we have these two restrictions we need to be careful. Where our number, the a value, is between 1 and 10, okay, and b is an integer. Okay, what does an integer mean? Well, pretty much whole numbers. Okay, it can be negatives or 0, 1, 2, 3, 4, 5, things like that. Okay, no decimals. Alright, so example 2. Which of the following are in scientific notation? Okay, so what I'm going to do is I'm going to see which one of these pass these two restrictions here. And this restriction here. We'll try to take a second and see if you can figure out which ones are in scientific notation. Alright, let's take a look at the first one. Well, it's in that multiplication setup, so that looks good. We have 10 to a power, and that's an integer right there, so that's fine. But look at this a value. This a value, is it between 1 and 10? No, it's not. So, you are not in scientific notation. How about the next one? Let's see. Well, we have 10 to the second power. Okay, that's good. Times, and this is 1.2. That is in between 1 and 10. So this one passes. B passes. Okay, this one is obviously not in scientific notation because it is not something times 10 to a power. Okay, you do not pass. How about this one? Well, okay, that's between 1 and 10. That's good. We have the multiplication. We have 10 to a... Oh my goodness, can we have a negative power? Yes, we can. That's perfectly fine. The negative power works, so this is in scientific notation. How about this one? This number is not between 1 and 10. Okay, so this is not in scientific notation. Alright, so here's a slight different thing. This question is which ones are in standard notation? So how do we remember the difference between standard and scientific? Well, standard notation is what you would see normally on like someone's check. If somebody wrote you a check, you would not see them write out a number like 1.2 times 10 to the second power. Normally on a check, you might see $150, if you're really lucky, $1 million maybe. Okay, so we're looking for something that is not in scientific notation. So this one, you would definitely not see that on a check. You would not see that on a check. You would, hopefully, that would be really wonderful to see this on a check. Okay, so that is standardized notation. This one is not something you'd see on a check. This one would be a really, really sad check amount, but sometimes you do see decimals on a check. Alright, so there we go. Those are standard notation. Alright, so we're going to write the following in scientific notation. Okay, which means we need to find a way to rewrite each number as a times 10 to a power. All right, so what we do is basically you're going to be moving your decimal point. Okay, that's the whole plan. Move your decimal point to the way you want it to be. All right, so where is the decimal point in the beginning? That's a great question. Well, the decimal is actually right over here. Okay. So I'm going to move it as many times as I need to until I can get a number between 1 and 10. At the moment, this number is definitely not between 1 and 10. Well, if I move my decimal 1, 2, 3 places, that's 21,030. That's still not between 1 and 10. So I'm going to keep moving my decimal until, oop, that's 21, almost there. Aha! I have now hit 2.103. So the number 2.103, that is between 1 and 10. Okay, but I just moved my decimal. So because I moved my decimal, I need to balance that out by multiplying this by 10 to some power. All right, so what we're going to do is count how many times our decimal moved. So how many times did it move? 1, 2, 3, 4, 5, 6, 7. Okay, so we'll write 7. That's the number of times my decimal moved. And then the question is that going to be a positive or negative 7? Well, how I remember it is, if our exponent is a positive number, that means my original number, before I translated it, was a big number. Okay, so think of it. In your bank account, if you have a large amount of money, that's a pretty positive feeling, right? But if you had a negative or a super, super small beginning number, that would be a rather negative feeling. So that would be a negative 7. Okay, but we started with a really large number. So our 7 is going to remain positive. Okay, so a way I remember it, large number, positive experience, small number, negative experience. Okay, or small number meaning decimal. All right, so there we go. We have successfully turned that into scientific notation. All right, so here we go. Okay, this one is exactly the opposite. That number was huge. This one is a teensy-weeny number. So, as usual, when we're trying to get into scientific notation, we're going to look for the decimal. Where is the decimal? Right there. Okay, and we're going to move it as many times as necessary until we get a number between 1 and 10. So let's see, 1, 2, 3, 4, aha! I have made the number 4.05. And my pen is trying to die on me. All right. But remember, to balance that out, we need to multiply it by 10 to... Okay, pause the video, try to see what number you're going to put above the 10. All right, so let's see, we moved it how many times? 1, 2, wait, what was that? 1, 2, 3, 4? And then the question is, positive or negative? Well, my original number was a decimal, which is really, really small, so it's going to be negative. Okay? All right, and there we go. Scientific notation. All right, so for part D, we're going to do the exact opposite. We're given scientific notation and we're asked to return it to standard notation. Okay, so first thing I'm going to do, I need to figure out which direction to move my decimal. Am I going to move it to the left or to the right? Well, to figure out which one we're going to do, you take a look at the exponent. That's a 5. Is it a positive 5 or a negative? Well, it's a positive, which means it used to be big. Remember, positive experience in your bank account, big number. Okay, so to make this number bigger, I need to be moving the decimal to the right. Okay, so we'll start with 3.02, and I'm going to move it to the right. 1, 2, 3, 4, 5 times. How did I know to move it 5 times? Because that's what the exponent told me. Okay, once you've moved it 5 times, just fill in the blanks with zeros. And there you go. All right, so a good way to check if you moved your decimal in the right direction is say, since it was positive, the number should end up big. Is that a big number? Yep, that's 302,000. All right. Okay, so take a moment and try to see if you can solve that one by yourself. All right, let's see. As usual, we start with the exponent to figure out which way to move. That is a -4. So since it's a negative, we know it's a decimal or a small number, which means we're going to move to the left. Okay, so here we go, 5.2. We're going to move to the left 4 times. 1, 2, 3, 4. Put in that point. Fill in the zeros. 1, 2, 3, 4. Okay, let me just rewrite that a little better looking. Notice I add that 0 before my decimal. That's a good habit to get into, especially if you plan on doing anything technical with math skills, like either veterinary or something like that. All right. And there we go. We went from scientific to standard notation. All right, part E. Ooh, do as indicated. So what is being indicated? Okay, multiplication is what's being indicated. I have 1.2 times 10 to the 5th power times, okay, these parentheses here, that means times. Let me change my pen color here. That means times 5 times 10 to the 8th power. So what I'm going to do to make this, oops, sorry for whacking the table. To make this less super symbol filled, I'm going to get rid of the parentheses since it's just multiplication. So that's going to be 1.2 times 10 to the 5th power times 5 times 10 to the 8th power. All right, and because this is all multiplication, multiplication is commutative, which means I can move the numbers around. So what I'm going to do is I'm going to move the decimals near each other and the tens near each other. So that's going to be 1.2 times, I'll move the 5, times 10 to the 5th power times 10 to the 8th power. Okay, so you might be asking, how come you just moved everything around? It's because these are all being multiplied to each other. There's no addition or division hanging out. It's just all multiplication. So when I see that, I can move the numbers around just fine. I'm not going to be breaking any math rules. All right, let's see. Well, I'll multiply these two together. 1.2 times 5. Ooh, that pen died. They've been sitting too long. Okay. 1.2 times 5. What is that? Let me pull out my trusty sticky note. 1.2 times 5. Let's do that by hand. 1.2 times 5.